Hello and welcome to the Data Engineering Podcast, the show about modern data management. Data teams everywhere face the same problem. They're forcing ML models, streaming data, and real-time processing through orchestration tools built for simple ETL. The result? Inflexible infrastructure that can't adapt to different workloads. That's why Cash App and Cisco rely on Prefect. Cash App's fraud detection team got what they needed: flexible compute options, isolated environments for custom packages, and seamless data exchange between workflows. Each model runs on the right infrastructure, whether that's high-memory machines or distributed compute. Orchestration is the foundation that determines whether your data team ships or struggles. ETL, ML model training, AI engineering, streaming, Prefect runs it all from ingestion to activation in one platform. Whoop and 1Password also trust Prefect for their data operations. If these industry leaders use Prefect for critical workloads, see what it can do for you at dataengineeringpodcast.com/prefect. Are you tired of data migrations that drag on for months or even years? What if I told you there's a way to cut that timeline by up to a factor of 6 while guaranteeing accuracy? Datafold's Migration Agent is the only AI-powered solution that doesn't just translate your code. It validates every single data point to ensure perfect parity between your old and new systems. Whether you're moving from Oracle to Snowflake, migrating stored procedures to dbt, or handling complex multi-system migrations, they deliver production-ready code with a guaranteed timeline and fixed price. Stop burning budget on endless consulting hours. Visit dataengineeringpodcast.com/datafold to book a demo and see how they turn months-long migration nightmares into week-long success stories. Your host is Tobias Macey, and today I'm interviewing Hannes Mühleisen and Mike Raasveldt about DuckLake, the latest entrant into the open Lakehouse ecosystem. So, Hannes, welcome back. Can you just start by giving a brief introduction?
Yes, certainly. Thanks for having me back. Pleasure to be back. Yeah, my name is Hannes. Yeah, I'm many things, but I'm one of the people behind DuckDB and more recently DuckLake. Started together with Mark the DuckDB project 7-8 years ago, something like that. And we're still at it. People tell you databases take 10 years and they may be right. And these days I am leading DuckDB Labs, the company behind the DuckDB project.
And Mark, welcome to the show. Can you give a brief introduction as well?
Yeah, thanks for having me. It's a great honor to be here. So I'm Mark. I'm currently the CTO of DuckDB Labs. So we're all technical. We're both technical, of course, but doing a lot of the programming, pull request reviewing behind DuckDB. And we started DuckDB 7 years ago. I want to say it's 2018, I believe, or maybe it was 2017 actually.
18, I think.
18. Yeah. It's funny the way, like, after a certain period of time, you can't recall the exact year anymore. Me and Hannes started it during my PhD, where Hannes was my de facto PhD supervisor, and we built it up. And now we're looking to revolutionize the Lakehouse space as we did with the database space. I think that's fair to say.
And so, Hannes, do you remember how you first got started working in the area of data?
Yeah, I do remember. This has been a while. Way back when I was a 16-year-old PHP programmer that had to store some data, and then people told me you need to talk to something called MySQL. And I had no idea what it was, and I didn't know what it meant. And but I sort of, started sort of mucking around with it. And at some point I realized that this SQL part was actually more interesting than the PHP part. And I went on sort of the classical thing where I studied CS, computer science, get my PhD in computer science, and then worked as a postdoc at a database research group here in Amsterdam. So it's been a while, but I'm still obsessed with tables after all these years.
And Mark, do you remember how you got started working in data?
Well, actually, because of Hannes. So I was following at my university, I was doing a master's in computer science, and I was taking a database course. It was I forgot the exact name. It was the master's, like, advanced database management course. And at some point they had a guest speaker, a certain Hannes showed up from the Center of Math and Computer Science, the CWI, where he presented the database system that they were working on at that point, MonetDB. And I thought, I never really thought about of course I knew how SQL worked, what a database was, but I'd never really thought about the concept of creating a database, like the backend. And I was like, that sounds super interesting. So I reached out to Hannes and I asked him, like, could I do a master's project there? And I did. And I had a great time doing it and kind of just stuck around. So after that, I did my PhD there, postdoc, and now we're running a company together. So.
And so DuckDB, as you've pointed out, has been in the works for a long time. It has grown to be massively popular, used all over the place. So I'm not going to dig too much into that. And we actually did a previous episode about DuckDB specifically, so I'll link that in the show notes. But most recently, you've introduced this idea of DuckLake, which was a bit of a shot across the bow to the whole Lakehouse ecosystem, which has been investing a lot into Iceberg, and obviously the Databricks folks have been investing a lot into the Delta format, and then there's Hoodie, and I'm sure many others that I am leaving by the wayside. Also, interestingly, there's the Lance table format focused on vector indices. And so given the breadth and variety of the ecosystem, I'm wondering if you can just give your summary of what is DuckLake and why.
Yeah, happy to. So I think what DuckLake is, it's a sort of a reimagination of Lakehouse formats. And it came from basically us looking at the Lakehouse stack as it evolved over time. Because it started with something that was strictly file-based. If you remember, Iceberg v1. And to include at some point, it suddenly gained this REST catalog, and a similar development also happened over in Delta land. And we just looked at that stack at some point because we are obviously the people that have to implement this in the end, because people kept asking us to make support for these things in DuckDB. So we kind of were forced to look at this at a very technical architectural level, and at some point thought, hey, hang on, there's this catalog up there that has a database. Maybe we should use this for all. And so what DuckLake is a unified catalog and table format that basically uses a SQL relational database for all the metadata management and sort of standard blob store, object store for the actual data and delete files, which is cutting a lot of complexity out of, let's say, the stack, greatly simplifying it. And so that's kind of, I think, how we got there with this. Just looking at what is the tech stack of the existing solutions, and then applying maybe critical thinking to it, and then ending up with a different solution, and that is DuckLake. Is that fair to say, Mark?
Yeah, that's exactly it. Like a lot of people asked for support for these Lakehouse formats. And I think at its core, they are cool ideas. Like Iceberg is a great idea. Delta is a great idea. Like it's very nice to put structure on top of a bunch of Parquet files. And they have a lot of really cool properties like ACID, amazing. We're big fans of ACIDs, the database principle that is. And like they have a lot of cool stuff that solves a lot of very real problems that people ran into with just using effectively a bunch of Parquet files on S3 or your favorite blob store, right? So at its core, they're really nice. Like it's a cool technology. What got us hung up on them was basically the added complexity that was there when you were using them. And I think that you may think as a user, oh, I don't necessarily need to deal with that, right? It's my database vendor that needs to deal with it. But that's not exactly true. Like there's a lot that bleeds through that I think as a result of the underlying complexity behind the Iceberg format, as a user, you will face a lot of these challenges as well. And there's also a lot of limitations that arise from that. And so we were thinking, okay, how can we make this a more pleasant experience? So that's one of the things we always try to do is from a user perspective, how can we make it nicer to use? How can we make it more streamlined, more smoother so that it's easier, so that you need to deal with less, like juggle less stuff, right? That's one of our core sort of ideas behind DuckDB itself and also behind DuckLake. How can we make it easier to use while still keeping all the cool stuff that Iceberg and Delta that they revolutionize essentially over just having a bunch of Parquet files on S3.
And another interesting aspect of what you're doing with DuckLake is that DuckDB was very popular. It's very fast, easy to use, easy to get started with. But then people started saying, okay, this is great for single player mode. How do I make it multiplayer? The folks at MotherDuck did a good job of addressing that in terms of being able to take the principles of DuckDB and the interface for it, but scale that up to a warehouse size utility. And I'm wondering, now that you're introducing DuckLake, how that compares to the ways that the MotherDuck folks are thinking about their utility and what you're doing with DuckLake and what that Venn diagram looks like.
Yeah, that's an excellent question because, as you said, I think what we discovered with DuckDB is that at some point we declared a single player mode, sort of that we've won it on hard, right? Like you can put terabytes of data on a laptop and query it with DuckDB, no problem, right? Like that's pretty crazy. In fact, I think I still can't really believe it sometimes, right? But we, as you said, we never had a really good multiplayer story. It was like, yeah, you need to, I don't know, copy this file around, or I don't know. And so that indeed is also what one of the main reasons we came up with DuckLake is like, what would be the multiplayer mode in kind of DuckDB style? Like Mark said, with simplicity, ease of use, these kind of things. I think MotherDuck is also doing that. They've also just launched a DuckLake product. In case you haven't seen it, I don't work for MotherDuck, but I just want to point it out. I think the difference is that MotherDuck is running compute for you, and that's kind of what they do, right? And DuckLake is something where you run compute yourself, or you can run compute yourself, right? You're running a bunch of nodes. Could even run this on your customers' iPhones if you wanted to. And there is a centralized metadata server that could be a hosted solution. I mean, I can also see that one coming at some point. But it is more, the compute is more on your side of the fence. And with MotherDuck, the compute is more on their side of the fence, where they're running VMs, they're doing stuff that might be DuckLake stuff, but in the end, it's still under their control, right? Which is some people prefer having a sort of, here's my credit card solution, and some people prefer building a custom solution. And so I think this is how these things are different.
Yeah, DuckLake is much more of a storage solution. Like here's how you can share data across nodes using pure DuckDB. And as mentioned, it integrates actually quite nicely with MotherDuck, because if you want to use MotherDuck with open table formats or like Parquet files essentially, right? So that you can maybe also use other services. Like there's a lot of reasons for a user to want to use Parquet files, because it allows you this interoperability between different tools. Maybe not every tool has all the solutions. You may want to grab a different tool from time to time. So there's a lot of value to having a bunch of Parquet files as your data store. And DuckLake essentially enables also MotherDuck to offer that as an experience for users. So in some sense, it's also good for them, and they are offering this as a product as well.
I think one of the most interesting aspects of what you're doing with DuckLake is that it changes some of the calculus around the broader ecosystem, where, as you said, Iceberg is already supported within DuckDB, so people who are in the DuckDB ecosystem can interoperate with Iceberg tables as well as their own local files and the various other extensions that DuckDB supports. Iceberg and Delta have a massive ecosystem that they have grown up and invested in, with multiple different engines that are compatible with those formats, including some of the vendors like Snowflake and Databricks adopting support for Iceberg. One of the main driving factors for things like Iceberg and Delta was that they were a means of being able to apply these large scale out compute stacks to these large data sets, thinking things like Trino and Presto and Spark. And so there's an interesting overlap there as well between that big data ecosystem and the analyst single player mode, I just want to do things fast and easy with DuckDB ecosystem. I'm wondering how you're thinking about the particular personas that are best served by DuckLake and how you're thinking about its role within that broader ecosystem.
I think that's a great question. I think that the way we built DuckLake is that it actually it scales in kind of deployment footprint, right? So you can make a tiny DuckLake instance. It's actually quite easy. It's like you install DuckLake and you say, attach DuckLake so and so, and it just runs, right? Like it's like a single line in DuckDB. And on the other hand, you can have a gigantic DuckLake setup where you have thousands of compute nodes, you have a gigantic metadata server, you have a gigantic S3 bucket or some other storage system, and things in between, right? So you can, and I think what is interesting about DuckLake is that its deployment weight goes basically as big as you want and as small as you want. And that's, I think, something we've seen that's maybe not as pronounced with the other approaches, where like the tech stack to run your own, let's say, for example, Iceberg installation is quite heavy, actually. And so you wouldn't be able to just stand that up locally for like in a couple of milliseconds. That's just not going to happen, right? So that's one aspect of DuckLake there. I think the other aspect of that's I think is also interesting is like that we actually thought about. It's like, let's say you want to throw a Spark at a DuckLake instance, right? What that be looking like? And we actually did a demo. That's like, I don't know, 50 lines of Python code to make a scale out querying from Spark on top of a DuckLake work, right? It's actually quite funny because we abuse the parallel partitioned JDBC reader for it, because DuckDB can pretend to be a JDBC server inside. Anyways, it's quite funny to see that solution. But the result is that you can basically have a Spark running a giant scale-out query on top of a DuckLake instance. You can also do something orthogonal to it and say, I'm going to run 1,000 nodes that each run a single or a different query on the same DuckLake at the same time. That also works, right? So I think you have a lot of sort of possibilities there, and DuckLake as a concept doesn't really, I think, bind you to one specific way of doing things. And I think that's something that we really like as an architecture, right? Is that you can say, what do I need? Yes, I need this and this. It does make things a little bit harder for our DevRel team that ask, what on earth is this for? What on earth is this useful for? And we say, anything really. It doesn't really help, but I think there's a ton of flexibility there, and I think we've seen a lot of appreciation over the last couple of months.
Yeah, and I think in particular, what I would say is a good use case for DuckLake as opposed to the traditional stack of Lakehouse formats is that because it is so much easier to set up and use, if you as a company want to set up your own stack for this, I think it's going to be much easier to use DuckLake than to set up all this infrastructure on Iceberg. So I think if you're a Snowflake customer, right? They have loads of engineers. They're very smart people. They have figured out how to set up Iceberg. It's great. If you want to then, as a user, plug into your Snowflake cluster using their Iceberg support, works very well. But once you actually want to start running this yourself, right? Like you don't want to use Snowflake, but you want to self-host a Lakehouse architecture, I think that's where the simplicity really kicks in. And I think especially for smaller companies that may not have that big of a footprint, it makes a lot of sense to go for simpler solutions. And what we're trying to do as well is to make sure that it scales up as you go. So that it's not just this is like my prototype stage sort of development, but it's easy to use for your prototype, but it scales up as much as you need it to also as your company grows.
On that point of scale, one of the ways that is addressed is with the horizontal scalability of I'm going to have one coordinator node that figures out what is my query plan, and then I'm going to farm that out to multiple worker nodes to actually do the data retrieval, push down query processing, figure out which Parquet files I need, pull them up, pull the bits of data out that I need, shuffle that all back together and send it back through the coordinator node. And I know that at least in the case of DuckDB as the client, you can do some scale out in terms of the available number of CPU cores up to the capacity of the memory of whatever piece of hardware you're using it on, but it's not going to natively scale out across multiple machines. And I'm wondering how you think about that aspect of scalability versus the scalability of usage, where 15 different people can each run their own DuckDB client, and I don't have to worry about paying for 15 different VMs for X number of hours when somebody might be using it.
Quick objection there. DuckDB is not limited by the available memory anymore. So that's no longer the thing. We are now limited by the available disk space. So that's a much better limitation. But you're absolutely right. And I think at this point, it's important to distinguish between DuckLake, the concept, and DuckLake, the extension for DuckDB that implements DuckLake, right? Like these are two different things. They may have the same name, but that's just the way things are. So I think the DuckLake as a concept is just, hey, here the metadata is all in the SQL database. Hey, all these files are on S3. Nothing keeps you, and I've mentioned it, nothing keeps you from gluing Spark or Trino or something else to that concept, right? And say, look, instead of reading a bunch of Avro files and JSON files and stuff and REST and whatever, go ask this SQL database for which files are relevant, which filter pruning we can do, the query planning bit. And then you do your normal Spark or Trino thing for the scale out and what you said for, pulling stuff from Parquet files, shuffling, all that stuff. That's the concept can do that, right? There's no technical reason why that can't work. In fact, as I mentioned, we have a demo doing this. I see, for example, I would not be surprised if Trino would be adding a capability for DuckLake in the near future, right? For example. And at the same time, you also have an implementation in DuckDB, that is the extension for DuckDB, that is the DuckLake extension, that doesn't have that, right? But that doesn't change the concept. It just means that if you're running DuckDB, at the moment you can't do this scale out thing, but you could, what you mentioned, for example, run 15 different local instances of it that all talk to the same DuckLake instance that's maybe on a centralized server, and that works perfectly well. So I would say this limitation to scale out or this design decision on scale out that you mentioned, that's on the implementation side currently. That's not on the conceptual side. The concept doesn't care how many nodes you run for a single query, but indeed the current implementation in DuckDB does have a single node limitation. Yes.
I actually, while you were saying that, just quickly looked to see if Trino already has DuckLake support, and there is an issue for it, and it points to the fact that there is the DuckDB connector, so maybe it already works.
It's entirely possible it already works. So again, we got this to work with Spark with 50 lines of Python. So it's, if anybody's interested, I think we have a Blue Sky post somewhere.
Yeah, I think that's pointing towards the DuckDB connector. I think that's another interesting consequence of DuckDB being an in-process database, is because DuckDB itself is a library you can embed into a program. You can use DuckDB as a sort of gateway to DuckLake through the DuckLake extension to make it much easier to do these kind of implementations. So that's actually, instead of building a dedicated DuckLake plugin for, say, Spark, you could also very heavily lean on top of DuckDB's implementation, which makes your actual implementation like maybe a few hundred lines of code. Like, it makes it way, way simpler than if you had to yourself handle all of these complex things. And it's one of the things that we are also thinking about as we're developing, is adding these sort of methods that allow partially shifting the work to other engines. So for example, we have the method that allows you to add Parquet files directly, as opposed to using DuckDB to write the Parquet files. Then you can write a bunch of Parquet files using your engine of choice, be that DuckDB, be that Spark, be that Trino, register them using DuckDB, and then you no longer need to have that sort of native, like, complex integration in Trino directly. You can just lean on DuckDB's implementation.
But I think it was a bit of an accidental thing that we realized, hey, this actually works really well, right? I don't think we actually planned this. It was just like, oh, hang on, we can just use DuckDB, what you described, Mark, right? Like, we can just use DuckDB on, let's say, all of these workers of a scale-out solution because it's lightweight enough to basically just run it on all the workers. And presto, we can use these, and it's already working. Like, that's funny because I think we have been working with Databricks for a while to work on the Delta kernel project. I don't know if you're aware, but they're building this kind of library that allows you to interact with Delta tables easier in a simpler way, because they wrap a lot of the complexity. And we've kind of inadvertently built something similar there because, hey, you can just run DuckDB on these nodes, right? And that works perfectly well because DuckDB is so lightweight. And yeah, it's just a JDBC driver or something.
And because it also has the integration with the Arrow ecosystem, it makes it very easy for interoperability with that whole suite of tools, as well as the fact that you can either via Arrow or DuckDB embed it in something like a Ray cluster or a Dask cluster as well for that horizontal scalability.
Yeah, there's some things we might want to do on this. So one thing that we might want to do to support this better in the future would be to say, hey, we'll expose some units of parallelization for you, right? Like, you're an engine, and say DuckLake, tell DuckDB the DuckLake extension that if you want to run this, and it will tell you, hey, look, here's these 475 tasks I have for you. And then maybe there's another way of interacting where you say, now I want to run task so and so, right? Like, you could imagine some multi-stage kind of interaction model with DuckLake that would only make sense if you're running from a distributed engine, but we would be perfectly able to expose that kind of thing and make that a very smooth experience indeed. I think that's also something that came up after we released DuckLake first and realized what kind of stuff people got excited about, right?
So jumping back to the position within the ecosystem, there are these table formats, there is this investment into the interfaces that they provide, whether that is directly via the metadata layer or through the REST catalog in the case of Iceberg, or the Unity catalog in the case of Databricks, DuckLake in and of itself doesn't necessarily prevent you from being able to use some of those same concepts and primitives from the consuming side. And I'm wondering how you're thinking about the integration path, either by migrating from Iceberg to DuckLake, or being able to interoperate between DuckLake and Iceberg or Delta. And in particular, if you have a REST catalog implementation, why not just put DuckLake in as the implementation detail and get rid of all of those JSON files that you have to shuffle around in the backend?
Maybe that's something for Mark, since you have spent so much time on this.
No, absolutely. Yeah, I think that's definitely something that we are looking into, is basically making DuckLake a backend for the Iceberg REST catalog. Because as I see it, the Iceberg REST catalog, in spite of its name, is not actually that tied to Iceberg. And they're trying to further and further detach it from Iceberg. And actually, they have to do that. So the Iceberg, the table format that has the JSON files, the Avro files, there's a lot of inefficiencies because you have all these files. So basically, in order to get rid of these inefficiencies, you want to get rid of these files. So if they are going to solve these problems, the inefficiency problems in that catalog implementation, they have to make that transparent. They have to make it so that the APIs, they could be backed by the files, but the data could also live elsewhere. Of course, once you have achieved that, right, like once you no longer need those Avro or JSON files, at that point, you may as well say, oh, actually, I don't need the Iceberg table format at all anymore, and I can just put DuckLake behind the Iceberg REST catalog. So it's also, I would say that in spite of the name, these are two very distinct things. And we may actually have a future where there is an Iceberg REST catalog that's backed by DuckLake, and maybe that's even like the most popular approach. That's very possible, because there are advantages to putting a REST server in front of your Lakehouse solution. Like, it does offer a bunch of advantages that you would not get otherwise. And of course, there's also the interoperability that is important.
Maybe on the interop, I should also mention that in DuckLake, we have blatantly stolen the Iceberg format and conventions for writing the table files on Parquet and to write the delete files on Parquet. So those are compatible. So you can actually have if you have an Iceberg table sitting somewhere, you can basically instantiate a DuckLake table on those same files without touching those files. That's pretty cool to do. And obviously the inverse would also work. You could have these files and then stage them in a Iceberg transaction later on, and that would work without actually rewriting those files, because we just decided to that there was no actual technical reason to diverge from whatever Iceberg was doing, and so we just used the same sort of conventions there. I think we're pretty close on an import feature. I'm not entirely sure.
We actually have an import feature.
Oh, there we go.
So it will land soon. There's an import from a conversion from Iceberg to DuckLake, not from DuckLake to Iceberg yet, but that will also come.
Right. And so then you can basically, you can pull down, I think it's an interesting use case where you can pull down a snapshot from an Iceberg table into DuckLake and then carry on there. I think it's always important for new things to be, let's say, flexible on import, right? Like that's one of these things.
That also helps to address my next question, which was going to be that in terms of Iceberg as a format, it is very conducive to a process that is completely naive and unaware of the actual catalog that is managing multiple tables, where as a process, I can just write the Parquet files, I can write the metadata, I can be a purely file-based operation and not have to worry about integration with any other APIs or manage database connections and those permissions. As long as I have permission to the object store, I can actually maintain my own Iceberg table in isolation. And from an integration perspective, that's very beneficial because I don't have to worry about those added complexities. Whereas with something like DuckLake, where there is that SQL process involved, I would need to be able to write to the object store as well as write to the database backend that is managing that metadata. So it adds an extra step and an extra set of complexity. But if I'm able to write it as a pure Iceberg table via files only and then incorporate that into DuckLake via an import process, it helps manage the ease of integration and adaptation for that broad ecosystem of connectors that already exist for being able to write Iceberg format.
I agree, but I'm actually wondering, maybe you see more of that than we do, but I have this impression that the pure file-based version of Iceberg is actually like kind of deprecated at this point. And I mean, I had some discussions with people in the Iceberg sort of world on this at some point. I was like, hey, I love this file-based thing. Let's do that. And they said, no, it's all we're actually not going to be able to commit a change without talking to the REST catalog in the very near future. I'm not entirely sure where they are on this discussion at the moment, but I had this impression that they are moving or have moved basically to this world where it's no longer enough just to stage a bunch of files. I'm not sure what your take on that is actually.
So in particular with the DLT implementation of Iceberg, if you're using their open source version, they don't have any integration with the catalog. It's purely, they will write the Iceberg table and the metadata. It will use a SQLite catalog for the purpose of the actual transactions that they're conducting, but it is left as an exercise to the user to actually manage the catalog integration after the fact. Another interesting element within the ecosystem is the S3 tables support for Iceberg, where the bucket itself is responsible for managing the table metadata and the catalog. And so that's another interesting evolution of that ecosystem where they're trying to remove that piece of complexity from the consumer.
That's a fair point. We're actually working with the S3 tables team too on that exact sort of aspect of how to make the integration with S3 tables as painless as possible, which is kind of what we are specialized in here at DuckDB, at removing as much pain as possible. But in this case, I think that yes, you're right. There is an additional complexity. Well, compared to purely file-based approach. Sorry, Mark.
To add to that, DuckLake can be purely file-based as well, because you can also use a SQLite or a DuckDB file as your database. The only limitation there is that you cannot directly attach or write to a database using only an object store. So your database, your metadata store, needs to sit on a regular sort of SSD or hard disk-based medium. But that is also a limitation for SQLite, of course, if you're using that as your Iceberg REST catalog.
Now, in terms of DuckLake specifics, obviously it simplifies the implementation stack where you don't have to worry about the proliferation of files, having to read all of the files before you can write the latest transaction. And then if you have multiple writers, then you have conflicts where you have to do multiple round trips before you can be sure of your commit. What are some of the other capabilities beyond Iceberg that DuckLake either does or can offer? In particular, I'm thinking about things like proper primary key, foreign key constraints, indexing, etc.
We unfortunately, we don't have indexing or primary key, foreign key constraints. It is interesting. It is technically definitely possible, but there is a very high cost to pay that I think most people will likely not want to pay. Maybe that is not true though. Like, I think it's a very interesting question. Like, what is the cost that people are willing to pay in order to get constraint verification in these kind of systems? But as far as I'm aware, I don't think there's any sort of blob-based system that really supports primary foreign key constraints. Like all the traditional database engines like BigQuery and Snowflake, they don't really have support for this. And also all the other Lakehouse formats don't have support for this. It would be interesting, but it's not really. I think the cost of doing this for large data sets would just be prohibitively expensive, essentially, to the point where you probably don't want to do this if you're going to have any sort of scale. And if you're not, then maybe a Lakehouse format is not the right format. But maybe that's also, again, maybe I'm wrong about this. Maybe there is a desire. As for features that DuckLake has, I think one of the cool features that we have is the data inlining feature. So effectively, when you write data to DuckLake, you don't necessarily need to write it to a Parquet font S3. If your change set is small enough, you can also write it directly to the metadata store. And the way that you can think about this is it kind of makes sense. If you're writing a Parquet file to S3, right, you're already writing some data to the metadata store. You're always writing like, okay, where is my file? What is the min-max values of these columns, right? You're already writing like a bunch of data there anyway. If your data is small enough, it may be about the same size as the metadata you would write. So why write the file at all? And that gives you kind of a nice thing where you can write data into the metadata store if you have like very small, right? So you can insert like 10 rows, 10 rows, 10 rows into the metadata store. And at some point, you can then write that out to a Parquet file, essentially using the metadata store as a sort of buffer. And what's cool about this compared to like standard buffering approaches is that that data becomes immediately visible. So because it's part of the same transactionality as your metadata, you insert your 10 rows, and instead of having it sit around in some buffer where you cannot query it, it is immediately visible, follows all the same principles, all the same ACID principles, like it's immediately there. And that's very important because otherwise, like what you generally see on top of things like Iceberg is that you have a buffer, probably some Kafka stream or something, that keeps data around for a certain number of seconds or until a certain data threshold is reached. So it's like, okay, I keep data around for like 5 seconds or until I have 100,000 rows. What ends up happening in practice is you always hit the 5-second threshold because probably you're not streaming enough data. So you end up writing like tiny files every 5 seconds anyway. You have that 5-second delay. Like there's a lot of issues that basically arise from this buffering. Plus you have to do the buffering. And that's essentially solved by doing this data inlining.
That's really cool. I mean, this is something that, we have a database, we might as well use it. Another thing I really love about DuckLake is the encryption feature, because basically what you can do in DuckLake is you switch on encryption and we will generate a unique encryption key for every Parquet file we write out to object storage and actually store the key in the metadata catalog. And so what you now have is you can put your DuckLake on a completely untrusted storage, and whoever has access to it can do absolutely nothing with those files because it uses the standard Parquet encryption and they're just not readable to anyone else. I think that's really exciting because it means you can put them on your Cloudflare edge distribution thing, CDN kind of setup. Everybody can access them, but nobody can really do anything unless you have access to the metadata catalog, which has the keys in it. And it's really just a single Boolean configuration flag to switch this on, and we will just automatically do all that. I think that's also super interesting to have, because it fixes a lot of these kind of authorization problems that we see with people writing things to object stores, is where now you have to set up crazy policies or vend keys or things like that, where you go like, we are just gonna write encrypted files to this object store, and they're just unusable, useless to anyone else. So I think that's also a really cool feature. I was also want to point another thing out for DuckLake, which is more like, it's not like a qualitative thing, but we have Lakehouse formats and DuckLake have this concept of snapshots, right? But in these existing formats, a snapshot is actually quite expensive. And people are sort of discouraged from having more than n, where n is like a small number snapshots at the same time, right? Just because the way the formats are designed, there's just a huge cost of having a snapshot. For DuckLake, on the other hand, a snapshot is a couple of rows in a database, right? Like there's no significant cost from having an additional snapshot. And I think just being able to have thousands of snapshots sitting around and basically not caring too much fixes one of these, the biggest pains that we've seen from people complain about with existing formats, is that they say, hey, this works great, but once I start actually making changes, for example, to fix the freshness issue that Mark mentioned, we'll have thousands of snapshots, and that's actually not possible because then our JSON file explodes, which is of course this is a great problem. So I think these are some of the things we find really, really exciting about DuckLake, is that there's no such restrictions. Again, because these restrictions originally come from having everything have it be a file on object store in the same sort of domain as the data files, and we don't do that, right?
The permissioning aspect is another piece that I wanted to touch on, and in particular, I'm interested in whether, because DuckLake is implemented as largely a SQL metadata layer, how that plays into being able to control things like column-level access controls versus just row-level access controls that have become the predominant means of controlling what people can do. And to the point of encryption, what does DuckLake offer in terms of things like column masking for things like PII, etc.?
The column masking is a great question. I think in terms of like fundamentally, DuckLake has the same access control possibilities as other Lakehouse formats. In the end, your data sits in a bunch of Parquet files. You need to somehow regulate who accesses those files, right? So there's different ways you can go about doing that. The simplest way is like table level access control, where all your files for one table sit in a certain subdirectory, right? Like, so you have like schema / table / and then you have all the files for the table there. Then you can do access control on that directory. If you want to do a row-based access control, what generally happens in these formats is that you do partitioning, and then you can do attribute-based access control. So instead of saying, I control the permissions per row, because that's actually really hard if your data sits in a bunch of Parquet files, right? You make sure that the rows that you want to do the access control on end up in different files. So you can, for example, partition on your customer ID, and then your rows for one customer end up in a different file, then your rows for another customer. And then you can do attribute-based access control on those partitioning keys effectively. The column-based access control, that's very interesting. And I think that's where the encryption could come in, but this is not something that's currently supported yet. In the Parquet standard, it's possible to have different encryption keys per column, which would allow you to do column masking, like you mentioned, through the use of those encryption keys. So you could then have different encryption keys for each column. And because even if you can read the whole file, because that uses industry standard encryption algorithms, you will not be able to actually understand the data that is in those columns unless you have the encryption keys for each of those columns. And then you can do, the metadata server can choose which encryption keys to give you based on the permissions that are set. So it could say, oh, you can have the encryption key for the username column, but maybe not for the password column, or maybe you can have the city, but not the address, or like whatever PII you want to hide, you could do, like maybe not the social security number, but.
Yeah, and I think what's interesting is that this also reuses a bunch of existing and well understood mechanisms. So let's say you're using Postgres as a metadata server for DuckLake. That's pretty common. It's one of the ones that kind of we recommend, I would say. They have row-level access control, and you can use those row-level access control features on the metadata tables for DuckLake to, for example, like Mark said, hide the encryption keys for sensitive stuff from some users, but not from others. So indeed, it's not there yet, but I suspect we'll have support for column-level encryption keys, because why not in one of in some point in the future. And then you could even do that for columns. At the moment, indeed, as Marcus said, we are kind of restricted to the partitions.
The other piece that I'm sure listeners would complain about if I didn't ask is the vector type, where DuckDB has a vector type support. You can stick arbitrary arrays into Parquet files, and I know that the Starburst folks in particular have layered in some vector capabilities in their implementation of how they work with Iceberg, at least in their Galaxy product. And so I'm curious how you're thinking about the ability for storing and retrieving vector types within the DuckLake ecosystem.
Well, we don't have any immediate plans for putting vector indexes in there, but the vector type, the array type, these are definitely supported in the DuckLake format.
Yeah, like in DuckDB, right? Like, so we have this special vector type, and that you can use to store vectors, and that can also go to DuckLake.
Yeah, but if you want to store the vector similarity search index, currently that's not available for DuckLake.
I think we could imagine coming up with some story for indexes like this to also go to DuckLake, but it would, because many indexes can be represented as a table themselves, and you could use that, basically a recursive technology to store an index, but that's kind of future work. Hey, if you want to work with us on implementing this, let us know. but yeah, that's currently not planned now.
Yeah, I think it would be interesting to look at what the Lance format is doing as inspiration for the broader ecosystem of Lakehouse formats, and whether there is some possibility of eventual unification, at least on some of those aspects, if not in terms of the actual implementations.
Yeah, for sure. We actually met him last week, so it was kind of cool to talk, in the same room from different Lakehouse formats.
So the other aspect of what you're doing with DuckLake, obviously with DuckDB as the prime example and the initial implementation target is that the maybe de facto way of working with it is using DuckDB. DuckDB as a technology has already had a massive impact on the industry and how people think about where processing happens and what you can do at which locations. And so with the introduction of DuckLake, I'm curious how you're seeing that impact the way that teams think about the overall architecture and implementation of their data estate and what processes happen when and where.
Yeah, I think that's actually the thing we are maybe most excited about. We mentioned it earlier as the multiplayer capability for DuckDB. And so basically having a story that says, hey, I want to use technologies like DuckDB or open table formats, but I also need to have some sort of semblance of central control over, what is the truth. And I think we have now a story essentially saying, hey, look, here's our vision on how this looks like. And I think what is fascinating about it is it kind of takes this traditional 2-tier architecture or 3-tier architecture and flips it around, where like your client or your local machine is no longer sort of the smallest light in the architecture, but it's suddenly actually the prominent player, because it's where the compute happens. It's where where users interact with your local machine. It's the one that gets the query. It's the one that starts running things with local files, possibly remote, pulling in remote things. And then the point of achieving sort of consensus is basically going to the catalog and saying, hey, I would like to commit these things, right? That is, I think, fundamentally different from this traditional architecture where you have to sort of bow to the almighty data warehouse sort of overlords. And you would be lucky if you could get a thin trickle of data through this terrifying protocols that these things traditionally used, right? So I think it's actually quite fascinating. And as with DuckDB, you mentioned it has revolutionized the data architecture. I'm glad to hear it. It's like sometimes I'm a bit concerned about what we've done, but I think it's really fascinating to see this flip of the architecture. And at the same time, I think it's gonna take another 10 years till we've seen sort of the creative use cases, because we're only now starting to see the creative use cases of people doing stuff with DuckDB. Or it's maybe not entirely fair, but let's say the wildness of the things that people do with DuckDB is increasing by the day. And I think this is another one of these cases where it's going to take the community a couple of years to be like, oh, hey, we can do this now and it totally works. So for example, I'm going to be very excited once the first iPhone app that just runs a local DuckDB and with DuckLake to centralize some sort of data coordination using DuckLake pops up. There's no reason this cannot be done. This is actually the design can do it. It's going to take a while, I think, for data engineers to consider going a bit outside of what they know. But I think it's extremely fascinating to see this, let's say, authority flip almost, right? Like local first.
I think that one of the interesting aspects of what DuckDB has shown and has been mirrored with other projects such as KuzuDB and LanceDB is that the communal wisdom that data gravity is the most important factor in how you think about your overall architecture does not hold the same weight as it once did. Obviously, there are still aspects of that are real and we can't overcome the laws of physics, but there are use cases where the data gravity does not outweigh convenience. And so I'm wondering how you're thinking about that mode of thinking and the role that data gravity still plays and some of the ways that these newer utilities, as well as the investment in things such as Aeroflight and more efficient transfer protocols, helps to break that logjam of everything has to be centralized because that's where all the data is and I have to send my compute to the data, not the other way around.
Yeah, I think that is very fascinating because I remember that I was shocked when people started telling me about the disconnect of storage and compute, right? I think it took me way longer than it should have to accept that was the sort of the way of doing things TM, right? Because I still in my head had this idea of the Hadoop sort of era where lots of work was done to put that worker, executor, whatever they call it, onto the very node that the HDFS block was stored, right? And I think letting that go, it took me longer than I would have expected. And so, but once we accept that storage and compute are disconnected, I mean, what gravity is really left? Like, is it the data center gravity, right? Like we have to put it into the same AWS zone or whatever, right? Like, I think what's really fascinating there is that we got basically a way of running arbitrary code in these data centers. Something that's would have been unthinkable in the past, right? Like imagine 20 years ago, you're going to IBM and say, I need to run my gunky program in your data center. They would have said, absolutely not. Or I need to run my gunky program here next to your, national data storage facility. They would have said, absolutely not, right? But now that's absolutely commodity. So I think that I don't see a whole lot of gravity sort of remaining besides sort of between data centers, right? I think that's still something that people underestimate generally, but we do have this capability of putting stuff next to where the data tends to be stored. And with DuckDB, I mean, there's use cases where people put DuckDB on like a undersea rover because that's where the data is, and there's this very thin line going up to the surface, and then in these cases it still applies, but I think in the general case of data processing, it's no longer relevant. And I think it is true that these newer engines have simplified this. I think, like, if you think about the storage, like if the binary size of something like DuckDB is like, I think 40 megabytes at this point, right? Or maybe 25, depends a bit on the platform. This is something you can put almost anywhere, right? It's not like you have to run a Spark cluster there. And I think that has also changed the thinking. Again, for my taste, it hasn't started to change the thinking quickly enough, but then I always want more. So that's okay. But yeah, gravity, I would say I don't see a ton of it at the moment.
And so DuckLake is definitely a very interesting implementation. It's great to see new ideas entering the ecosystem. If I want to go and start using it today and convert all of my Iceberg tables into DuckLake, what is your recommendation for people who are eager to get started and they just want to jump on the new hype train and go all in on DuckLake? How should they get started? How should they think about what are the decision points about where to use it, when to use it, how to deploy it, etc.?
I think one interesting thing of using it, if you already have an existing Iceberg catalog, is you can use DuckLake as a local cache for Iceberg. So instead of always going back to your single source of truth, the Iceberg catalog, and looking at all these JSON files, these Avro files, you can use our Iceberg imports to already just use DuckLake as a sort of local version, local cache, if you will, of your whole Iceberg catalog, including time travel and all that stuff. I think that's a sort of interesting transition from Iceberg, where you can keep on using Iceberg in conjunction with DuckLake as well.
We should also put a small disclaimer here. DuckLake is currently version 0.2. And just from that version number, you should exercise some level of caution, right? So we are still in pre-release DuckLake. By the way, doesn't stop people at all from running this in production. This is something that has absolutely amazed me, right? Like we get like an email a week basically saying, yeah, we're running this in production, yada, 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 yada. And we go like, okay, cool. But honestly, we can sleep quite well because DuckLake relies heavily on very well understood technology, right? Like a Parquet reading and writing is well understood. SQL is also pretty well understood. Object stores are pretty well understood. So there's not like there's no like experimental compression algorithm involved here that would make us very, very nervous indeed, right? So I think that's why I think it's very cool to see that. I applaud the bravery of people. But to come to the disclaimer, we are expecting a 1.0 in the not too distant future. And at that point, we actually expect a spec specification to slow down a bit in development, right? Right now, there's still a lot of movement there. Well, not crazy amount, but there is movement there. And we expect that to slow down over time. But yeah, that's just a bit of a disclaimer there that it's still something that it's like 3 months old at this point. And I have to say, we are also getting emails all the time with people praising this. This is something that I didn't expect this. So when we came out with DuckLake in the first place, we were like, okay, we'll see what happens. But we got a ton of positive feedback of people saying like, yeah, this is exactly what we've been waiting for. Finally, a data lake format we understand. That was one of the sort of the biggest sort of things that we got there, is that because again, it combines well understood technologies. It doesn't rely on Avro, which is very obscure if you think about it.
And another piece that I'm curious about is, at least anecdotally, what you're seeing in terms of performance difference when querying across Iceberg versus DuckLake, particularly using DuckDB as the client since it has support for both.
Yeah, benchmarks are hard, but we have, well, let's say we did count the number of round trips you have to do to query an Iceberg table, and we did count the number of round trips that you have to do to query a DuckLake table, right? So this is like you going to talk to some other system, waiting for the response, and then proceed. I think for Iceberg, the number is 6 or something, or 7, and for DuckLake, the number is 2. Now, is that going to have impact on performance? Yes, probably it will. We are seeing much quicker round trips just because of the simplicity of it, just because there's no 7 round trips to object store or the REST catalog or things like that. But I think it's too early for us to say, oh, we're not going to put like a, hey, it's this many times faster than something else. It's also not really the messaging that we like, right? Like there is going to be a performance difference. I think there has to be, just because of the complexity involved. But we don't have really a number there. And it's not really the way we'd like to communicate about our technology. We want them to be convincing sort of on its own, right? Like we don't really, we can compare against ourselves from 5 years ago, great, but not like, I feel like it's not very classy to do that.
And another piece that I'm interested in is, because you now have a proper database as the metadata store, how does that factor into things like multi-version concurrency control at the Lakehouse level?
Yes. So the nice thing about having this database as your sort of central point of concurrency, of transactionality, is that it offers you transactionality on the entire catalog level, right? So you can do cross-table transactions, you can do like all the DDLs transactional. Like it really gives you like transactionality everywhere, which is very, very nice, and a property that I think many people appreciate. The other part of it is that because you have this sort of one-hop updates, you can have a lot more concurrency going on at the same time. Because if you do an insert into DuckLake, in the end, all you do is write a few rows to a database, and that's your hot path. So you can have many concurrent writers all inserting at the same time into the same DuckLake without any problems.
And so, recognizing that we're still very early in the introduction and adoption of DuckLake, I'm curious, what are some of the most interesting or innovative or unexpected ways that you've seen it applied already?
Yeah, I think one thing I wanted to point out is something people call the frozen lake. It makes me think of Disney, obviously, but the frozen lake, basically the idea of saying you have a data set that you update sort of kind of rarely, for example, official statistics or something like that. And you publish this using basically object store or a website, like a HTTP server. And like Mark has mentioned, we can put the metadata store in the form of a DuckDB file or SQLite file on the object store or on a website as well. And with that, what you can do is you can actually attach to this frozen lake in read-only mode from everywhere, taking advantage of content delivery networks. And you can see the entire history, you can see all the revisions, you can see all the changes that have been made. So it's really nice if you have some secondary process that has to look at, hey, has the official statistics thing changed? Okay, what were the changes? You can do all that, but you can't write, which is not the point. But then again, whoever maintains this data set has a nice path where they download the metadata file, they make their changes, they re-upload it together with the data files they changed. And it's a nice and defined process as opposed to, dumping a bunch of CSV files in a FTP server like in the old, like it's very common still, I hear it, right? So I think that's really cool, and we're gonna actually, some of the people we have authored a blog post that it's gonna come out in the next couple of weeks, I think, about this concept. So that was really cool to say, hey, look, we actually only need a read-only path, and it's already plenty exciting to have that, simply because it means you can see what happened, see the changes that happened over time, right? Like that's something I think that's very cool with DuckLake. Mark, did you see any other exciting use cases? I can't think of anything else at the moment.
I think the frozen lake is the most surprising for sure. I think what we've seen otherwise is a lot of people are using this for like basically whatever they would use the traditional Lakehouse stack for. One cool thing about DuckLake as well is that because you can run it completely locally, very easily and very efficiently, right? By just having a DuckDB file and a bunch of Parquet files locally, is that we've seen a few people try to use this for like offline analytics and stuff. So you can maintain a DuckLake completely locally and then essentially use that as your data store. And that then replaces what is often like either a DuckDB or SQLite database which then has the issue that it's not in like an open file format, or it replaces a sort of handcrafted, often Hive partitioned set of Parquet files that they have to patch around over, right? So there's this thing that if you want to use a fully local data solution, I think DuckLake works very well as well, actually.
That also introduces the possibility of DuckLake easing the divide between development and production environments, particularly in the case of things like DBT workflows, where I want to be able to test my changes without mutating the actual production data, but I also don't want to have to deal with making sure that I always have the credentials to a QA store or replicate the QA data. I can read from that production DuckLake environment and just write a new DuckLake to my local disk and then blow it away when I'm done with my testing before I ship my code somewhere.
I think that's also really cool. It's actually quite spooky. I think whenever I start using DuckLake locally, I'm always just like, okay, did this already happen? Did it work? And it's like, yeah, because it's not like you don't need 15 Docker containers. You need DuckDB, and that's enough to basically run a local instance, and that will have all the capabilities that a bigger instance will have in terms of like feature set. And so I think it's really fascinating for this local development. I mean, like we see with DuckDB, lots of people use DuckDB for local prototyping and tests and such, and we think that's great.
And to your point of Frozen Lake as well, because DuckDB has a WASM target, you can put the entire DuckDB metastore and client in your browser and not even have to have a server component for it.
Yeah, although some say that in our lab, we've already demonstrated read-write to Iceberg and DuckLake from WASM. So that's also something that's maybe coming in the future, that we can do crazy things there. You can also run the DuckLake metadata server in your browser. Nothing keeps you from doing that, obviously. It's kind of funny.
And so in your experience of working on DuckLake as a protocol, as an implementation target, and working with the community as they start the adoption path, what are some of the most interesting or unexpected or challenging lessons that you've each learned in the process?
That's a great question. I think actually what surprised me the most was that it wasn't that hard. Like, I mean, that's weird to say, but like when I first got acquainted with Lakehouse formats, I thought this was very complex, and I think it is. But then when we got started on DuckLake, I think at every step of the way, it actually, like, we didn't really face any big hurdles. Like, it all just kind of worked. And I think that's a testament to the simplicity of DuckLake, of course, but I think also to the building blocks that DuckDB itself gives you, because DuckLake, it builds on top of basically everything we have built in DuckDB in the past 8 years or 7 years. And it builds on all the connectors we have to the various database systems, and builds on our like a blob store integrations, the Parquet reader, Parquet writer, the asset we have ourselves, the formats we have ourselves. Like, it really builds on top of everything we have already built in a way. So I think it was, for me, it was very cool, a very cool revelation, kind of like, wow, you can do all this cool stuff actually very easy with all the tools that we have ourselves built here.
Yeah, and I think it's also what I mentioned earlier, what kind of increases our confidence in DuckLake as a concept, right? Because it uses components that we trust. So we have a higher degree of trust in our Parquet writer at this point, right? Like, we have a high degree of trust in our object store integration, right? Like, there's a lot of work by actually a lot of people here at, maybe want to give a shout out to the DuckDB Labs team here, where I don't know how many people at this point are working on these components, inadvertently kind of contributing to making at least the DuckDB implementation of DuckLake better, right? Like, somebody's working on adding a new object store, well, that can be used by DuckLake, by the DuckDB implementation at least, right? Like, somebody's working in a new database interface, well, that can be used by DuckLake as well, right? So there's, like Marcus said, we built on top of a lot that we have, but I think we're also improving all of these things constantly, which means that it's constantly getting better as well. So I think that's also really cool to see. And obviously, it's a big shout out to the team here that is pushing all these individual components like every day, right? Like, it's pretty wild. And so when we first came up with this idea for DuckLake, obviously we could build on all of these things.
And also to add to that, DuckLake itself has also improved the other Lakehouse integrations. So by building DuckLake, we built a bunch of components that are now being used in also the Iceberg and Delta integration. So it all kind of like it feeds into itself, which is very cool to see.
And so for people who are interested in this new format, they're excited by the premise of not having to manage all of these JSON files and all of the round trips. What are the cases where DuckLake is the wrong choice, whether the DuckDB implementation or the protocol itself?
So I think the limitations are very similar to the ones of other Lakehouse formats, right? So I think where it shines is where you have a bunch of like you want to have data stored in open formats like Parquet. You want to have data sitting in blob stores. I think that's where it shines. Once you don't have those needs anymore, I think other data formats could perform better. Like I think, for example, DuckDB's own database format generally performs better than Parquet files because it uses like more advanced lightweight compression algorithms that are not present in Parquet files. It has support for things like primary key constraints that are not in these Lakehouse formats that are not in DuckLake. So I think once you need to do things like that, like random access is a big one, right? Then like formats like DuckDB's own database format would perform better. And of course, also it is an analytical format, right? So it's designed for read-heavy workloads and for batch writes. If you're doing a lot of updates, a lot of upserts, things like that, like anything you would maybe normally use Postgres for, probably it's not going to perform quite so well in DuckLake.
And as you continue to iterate on the specification and the reference implementation, what are some of the things you have planned for the near to medium term or particular projects or problem areas you're excited to explore?
So we actually have recently published a roadmap for DuckLake. I think the things we're of course addressing a lot of the immediate things that are missing, such as adding more support for compaction, things like that are necessary for actually productionizing these workloads. Other things that we're excited about are we're adding support for variants, for geometry types. We're planning to add support also in the future, probably for things like materialized views, although that is a bit further out.
Of course, also just moving towards the 1.0 is also something that we're excited about. Like it's something that we noticed with DuckDB. Okay, it took us a couple of years, but like once we published the 1.0, it was really a point where lots of more people suddenly came to the project because I don't know, there seems to be some corporate rule that you cannot use 0.x software. But once we had released the 1.0, lots of more people came to it. And as I mentioned earlier, like as we kind of declare the current sort of specification to be more stable, I suspect we're going to see also just a lot more uptake, more serious uptake beyond kind of toy projects with DuckLake. So that's also something really interesting to see. But yeah, I mean, we're also quite blown away, I think, with the response from DuckLake, right? Like sort of almost overwhelmingly positive response. And we know we are kind of complicating a lot some of the Lakehouse world by throwing another format into the mix, and we apologize for that. But people reacted very positively to that, which was very nice.
Are there any other aspects of the work that you're doing on DuckLake and its position in the ecosystem or the implementation or adoption path that we didn't discuss yet that you'd like to cover before we close out the show?
I think one thing I wanted to maybe mention is that people sometimes ask us, yeah, but what if, Iceberg just adopts these ideas and then they just switch to a SQL-based backend, and then what about you? And then we actually say, well, great, we win. For us, we don't have to. There's also not a sense of winning and losing. But if, let's say, the ecosystem maybe admittedly or unadmittedly adopts some of these ideas, we also consider this a huge success, right? For us, at least we care really deeply about how people manage data. I think it has been way too complicated for way too long. And if anything we can do to improve that for sort of the average analyst out there, we are very happy about that. And whether that's at the end our Ducky logo on it or not, isn't such a huge sort of thing.
All right. Well, for anybody who wants to get in touch with you both and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
biggest gap. Well, if you knew, we would make another company, no? But I think there's still such a huge gap between what is kind of possible and what is the daily reality of the data practitioners. I think there's just such a huge difference in what could be possible and what people are actually doing. And we try to work on that with DuckDB. One of the reasons we did DuckDB was to narrow that a bit. But I think when sometimes we see, like who'll show us what they're doing and then, you just want to cry a little bit and be like, this cannot be the answer, but it's the best sort of what they have. It's the best I could do given the circumstances, often in corporate environments. And that's something that I think is like, it's almost like there's half of the population has to drive a car from the 1920s, right? That's kind of how it feels. And that would not be considered great, right? Like we would say, hey, let's maybe do something, forget these 1920s car people to maybe get a 1980s car. That would be really great, right? Like that would be a big, big improvement. But yeah, I don't think we're there yet.
The future is here. It's just not evenly distributed. All right. Well, thank you both for taking the time today to join me and share the work that you've been doing on DuckLake and for all of your efforts on that. It's a very interesting and exciting entrant into the ecosystem. So I appreciate the time and energy you're putting into that. And I hope you enjoy the rest of your day.
Thank you very much.
Well, thanks for having us.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.